Welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem number 53, maximum subarray. Before we do, I just want to ask if you guys could leave a like and a comment on the video because it helps me a lot with the YouTube algorithm, and a subscription to the channel really helps me grow. Alright, given an integer array nums, find the subarray which has the largest sum and return its sum. Alright, simple enough. Let's look at an example. Let's say we have the input here which is nums equals 5, 4, minus 1, 7, and 8. So what we could do at a very basic level is literally build all the subarrays. So we could just have 5 on its own, 4, minus 1, 7, 8. We could have 5 and 4. We could have, and remember that they have to be continuous, right? So we could have 4 and minus 1. We could have minus 1 and 7. We could have 7 and 8. And you get the idea, right? So we can basically build every single one. And it turns out that actually the best subarray is just to sum all the values. There's nothing that we can do better here. It's actually the subarray of 5, 4, minus 1, 7, and 8 because this actually has the sum of 23, and there's no way that we could actually get a better sum here other than just summing everything. So that's one way we could do it, and this would certainly work. But because we have to build every single possible combination, this is going to be very expensive and not actually what we're looking for. Ideally, we can solve this in one pass, which we actually can. We just have to be a little bit clever with how we want to approach the problem. So what we're going to do is we're going to solve this in a greedy manner. And what we're going to do is we're going to keep track of two variables here. So we're going to keep track of our answer, which is, whatever our best solution is. And we're also going to keep track of the current sum of the numbers as we go from left to right in the array. So in the beginning, our answer is going to be float minus infinity, because obviously we're looking for a maximum here. So typically when you initialize your answer, you just do it to minus infinity. And the same thing for the current sum. We can actually just initialize it to float minus infinity. And the reason that we actually can't initialize our current sum to 0 is because if all the numbers are actually negative, then this will actually skew our results, and we'd actually never get any sort of sum that's better than 0 because they'd all be negative, and then we'd actually return 0. So that wouldn't be right if there's no 0 and all the numbers are negative. So that's why the current sum also starts at negative infinity. What we're going to do is we're going to go over each of the numbers piece by piece. And basically, if the number would improve our sum, then we want to basically add it. And we want to be a little bit careful here with the negatives. So let's now go over piece by piece. So the first number is going to be 5, right? So what we're going to do here is we're going to check, okay, is the number that we have, 5, is it greater than our current sum? It is, because our current sum is currently negative infinity. And is that current sum actually less than 0? It is. So we're in the negatives, so we definitely just want to take 5 on its own. Even if we just took 5 as on its own, it would still be a better solution than current sum. So we're actually going to overwrite our current sum with the current number, which is 5. And then what we're going to do is, now that we've done one iteration through the loop, we're actually going to take the maximum here for the answer of 5 and whatever float infinity is. So obviously 5 is much bigger than negative infinity, so our answer now becomes 5 for the answer, right? And that's just keeping track of our best solution. Now we go to 4, and what we're going to do is we're going to see, okay, do we want to take 4 on its own, or do we want to add it to whatever our previous value was? So since 4 is positive and our sum is also positive, then we actually just want to add it to our value. We don't want to overwrite anything. So we're just going to add this here, and we're going to get 9. And again, we've now done an extra loop through. So we want to update our answer, which is now 9, right? Because that's the best answer we've had so far. So now what we're going to do is we've done 4, and now we're going to get to minus 1. So with minus 1, this is where things get a bit tricky. So obviously minus 1 is negative, and it's not greater than our current sum. So we don't want to just take it on its own. But the current sum is currently positive, so we do have some allowance to actually take this minus 1, because there might be something after the minus 1 which actually helps get us to, the optimal solution. So we can't just say because this one is negative that we just want to, ignore it and then stop our subarray here, because there might be things to the right of it which we actually do want to take. And remember, the subarray has to be continuous, so we can't just take the 5 and the 4, ignore the 1, and then take the 7 and the 8. We either take them all or we take them in pieces. So at this point, what we want to do is we're going to say, okay, well, I'm going to accept the -1, and that's fine. So I'm going to actually add it to my current sum. So it now decreases to 8. We take a maximum between our current sum, the 8, and the 9, and we'll see that, okay, we actually haven't improved our solution on this iteration, but that's fine. We still know that even if taking this was a mistake, we've still accounted for the fact that we could have had a 9 here, and that will be stored in our answer. So it's fine. If we end up having negatives in the rest of the array, we'll still have our answer as 9, and we won't be overwriting it because current sum will actually keep getting smaller. Hopefully that makes sense. So now we get to the 7, and obviously 7 is positive, and we want to add that to our solution. So now we're going to be at 15, right? So 15 is now our new best solution. So we update that. And as you can see, right, we took the -1 in hopes that something to the right of it will actually, we'll be able to add to our original solution here that we had. And now we've reached a new higher solution. So now we're at 15. We get to 8. Obviously 8 is positive, so we want to take it because it won't cost us anything. So we now get 23. And then we can update our new best solution with 23, which is actually the final solution because 8 is the last number. So that is what we would want to return, 23. So that's essentially the algorithm. We're going to go from left to right, and we're going to check, is our current number greater than the current sum? So the reason that we want to check this is because we could actually be adding negative values. And, if the current sum is negative and we get a value that's positive and also greater than, well, by definition, all positives are greater than a negative, but if our current sum is negative or the current number is actually really small, there could be a case that we actually just want to take that number on its own to just be the new subarray, because a single element, say it was like 10 billion, that could be so big that it's actually the best subarray just by itself. So if that number is greater than our current sum, and the current sum is actually negative, then we always want to just take that number on its own. Otherwise, we're just going to take the number and add it to whatever the sum is, and then at the end of each iteration, we're just going to take the maximum of the current sum and whatever best answer we've seen so far. And then at the end, we simply just want to return that maximum again. And the reason for this is we essentially just want to take the maximum at the end. So let's now go to the code editor and actually type this up. It's not that many lines of code. It's relatively simple. Let's see how we're going to implement it. In the code editor, let's type this up. Like I said, the problem is actually really easy. So we're going to say that our maximum sum, or whatever the answer is going to equal to the current sum. And remember, we set these both equal to -infinity, right? Now what we want to do is we want to go through each number in our numbers and basically check whether or not we want to add it to our result or we want to take it on its own in the case that the current result is actually negative. So we're going to say for num in nums, we're going to say if the current number is actually greater than our current sum and the current sum is actually less than 0, then we want to actually just take the number on its own, right? So we're going to say cur sum equals num. And this is the case, this is what we want to do when cur sum is actually negative, right? If our current sum was like -10, but then we got a value that was actually like 20, then it doesn't matter what happened before. 20 is already larger than everything up until that point. So we don't care about any of that. So we can just take 20 on its own because it's much bigger than the current sum up until that point. So we can just ignore it and basically just chop it out and now take 20 as our current sum because we don't want to worry about everything to the left because it might actually decrease our solution. So that is basically the only case where we set current sum equal to the number is when the current number is greater than our sum and the current sum is actually less than 0. So basically if the current sum is negative, then that's what we want to do. So otherwise, remember that we just say current sum, we're going to add whatever the number is to it. And then right before we go to the next number, we just want to say the new maximum sum is going to be the max of whatever the old maximum was and whatever the current sum is. And we'll check this at every single time we go through the actual each number here. And at the end, once the for loop ends, all we need to simply do is return the max sum. So let's just run this real quick. No syntax errors, perfect. Now let's double check that this actually gets accepted, and it does. All right, cool, solution accepted. What is the time and space complexity here? Well, time complexity, this one's pretty straightforward. All we do is iterate over all of the numbers in numbers, and all we do is basically either we're just setting a value or adding a value and taking a maximum. So all of those operations are big O of 1, and we do them n times, so that's going to be a big O of n runtime. And then for the space, as you can see, we don't actually use any extra space. We have two variables here, but they're just they're just storing values. They're not any extra data structures, so it's actually going to be big O of 1 in the space. So that is how you solve maximum subarray. Really good classic Leetcode problem. I think this is called Codain's algorithm, if I'm not mistaken. Although I could be mistaken, I don't know. I believe it was Codain's. Anyway, that doesn't matter. If you enjoyed the video, leave a like and a comment. It really helps me out with the YouTube algorithm. Seriously, you can leave whatever you want in the comment section. As long as it doesn't get flagged by Google, you're good to go. If you want to see more content like this, subscribe to the channel. If you want to join a Discord community with like-minded people where you can talk about Leetcode, prepping for interviews, systems design, you can have your resume reviewed, you can get referrals. If that sounds interesting to you, then join the Discord. I'll leave a link in the description below. Otherwise, thank you so much for watching, and I'll see you in the next one.